Welcome to OpenFoam tutorial. In this tutorial, we will simulate the flow through rectangular duct. The main objective of this tutorial is to set up the case in SimFlow, a new graphical user interface which I got from internet. So earlier I used to set up the cases manually by copying the folders from tutorials of OpenFoam and make the necessary changes in the files. I came across some free GUI like SimFlow and few others. I tried some and got impressed with SimFlow GUI. I downloaded the free version available in their website and tested it. Guys, I'm really impressed. Though it is free version with limited features, I'm really impressed. So in this tutorial, we'll try to explain the setup procedure with SimFlow. So let's go into the tutorial. Going to a tutorial. This is SimFlow graphical user interface. It can be used to set up the OpenFoam cases very easily. I have tried this GUI for some cases and I felt very happy. It is very handy in setting up the cases for OpenFoam. So this is the initial window where we can see workspace. And this is the My Cases folder where the case files are automatically saved. And we go here, the settings. So you can see the options here. So My Cases, here you can, once you click this one, you can see My Cases. Then you can click here to start the setting up process. So and then in the workspace details, the path, this is the path where the cases will be saved automatically by the GUI, and the storage is auto. So in this GUI, OpenFoam 2012 is installed. So this is the license details. So I have downloaded directly from the website, and the link is shared in the description. This is a free version which can be used, but some limitations are there. We can create only 200k nodes. Above this number, you cannot proceed further. It will generate the mesh, but you cannot proceed further to set up the case. So if you want to use this GUI, this free version, then one should take care that the mesh size is smaller than this. For some cases, we do have a workaround. We will discuss it later. So I go to My Cases, then here, new case. So the case name, Rectangular Duct, great. So this is the main case setup window where you can see various options here. New case, this load geometry. If you have any created geometry, we can load from here. Then some primitive options are given here. I think in the main version more options are available, but in this version we have only create box, cylinder and sphere. Okay, so we'll load the mesh here or geometry here. Yeah, this is the box geometry which I created. So the basic geometry is something like it. This is a simple rectangular duct. So now we need to create the groups, boundary face groups. So for this purpose, simple option is click the face, just press the control key and click the face, and then release the control key. Select this field and then press the escape field. So here we have separated one boundary face. Now we'll go for the others. Same process, we go here. Okay, I created the second inlet and outlet are created. Now I will select all these and group them as wall. So again, click field. I selected this face, the second one, third one, all these four faces in this field, and then click the escape. So now all the three groups are created. That is face, this one. So this is actually, you can check here in which direction. This is in the direction flow. So this is the outlet. Double click this and you can rename it outlet. Second phase group is the inlet. Double click inlet. Then the rest of the faces are walls. So double click this and write wall. Okay, so all the three phase groups are created here. Then we go to X mesh. Now click this field, surface groups. Then you can see the boundary layer mesh. So click this one. Then this window is open. So we don't change here for simple cases. I have now explored this, but then I will increase the refinement to 2 levels, and this default we don't touch that. Next we go to the field base. We need to create a auto domain or a control box where the mesh is to be generated. Then simply click this auto size. So the box around the geometry is created. So now we will use number of divisions. Mesh in X direction, I'll take 20 cells. In Y direction 20 cells, and in Z direction let us take 50 cells, 50 divisions. Okay, and no need to change all this, but see that these fields are in patch mode. Then go to point. Now we need to create a point within the domain where the mesh is to be created. For this point we will take 0.05. So it is in this one. Then we go to X. Yeah, so it has come so within the domain. And for Z let us take 2. So somewhere in this. Yeah, so the point is completely within the bounding box. Okay, now we go to mesh. So here serial and parallel options are available. For meshing we have serial option only. For running the case we have 2 processes here to run in this free version. So we go with serial option for meshing. So all other things done, you can press this, click mesh, so that the generation of mesh starts. So you can see here the mesh generation is started. It will take some time. So the mesh is generated. So you will get this. If the number of nodes generated are more than 200k, then you will a message will pop up, so that you have to reduce the number of divisions in the earlier window and remesh. So here luckily it is not the case, so the mesh is generated. Now we'll go further. Here we have seen 3 boundary groups: inlet, outlet and wall. So here we need to change this as patch, and again this also patch. So mostly all the flow boundaries need to be changed as patches. Then here wall, we can keep it as wall. Then we go to, so meshing is done. Then we go to setup. So various options for solver is available here. So I take steady state, incompressible, and simple solver. So now the SimFlow has a steady state, incompressible solver with turbulence, porosity, and rotating reference frame modeling. So let us select this. Yes, so simple. Then we go to the next step, turbulence. So various options are available here for turbulence RANs. Many models are there. Whichever model is applicable or required, we can use select from here. But in this case, we go with laminar mode only. And even large D simulation is also available here. We go with laminar. Then select transfer properties. So material database, I select air. Apply. Then no need to touch this for this case. Then we go to boundary conditions. Here we need to apply the boundary. So this is inlet. I apply velocity inlet, 0 gradient, surface normal, fixed flow. So the flow will go into the domain. So let us take 0.1 velocity, reference velocity. Fine. So we'll get this icon here. Then pressure outflow. We want pressure outflow here with fixed value and no need to change other parameters. So it is done. So wall no need to touch. Then we go to monitors. Now we'll create a section where we can see the contour plot. So come select this field sampling, then click this option, create slice. So I take 1. Okay, so it's something like this. So point is in y direction, we take 0.05 so that it is in the midsection. So click sorry, so click this option and see the section clearly. Okay, now you can see section created in the middle. So now select the fields which we need to plot their pressure and velocity. Done. Then we go to run. Here the case is steady state case. So we'll take some 300 iterations. And in output, we take interval as 10. So for every 10 iterations, one result will be saved. Now here the second option, clear all results files. So if we select this option like here, we click this, then we can write some number like 5 or 10 or whatever. So once the case is completed, the solver will delete all the files except the last 5 files. So here we don't want that. We want to keep all the results so that we can create an animation if needed. So for animation creation, we'll remove this option. So all the results at started, all the results at the interval of 10 will be saved. Save the case here. Now when you go and check the case file which is created, so Rectangular Duct, you can see all the folders as required by OpenFoam are created here. So constant, and even a mesh is created. So no manual operation, and this is very excellent. Then we can run the simulation. So now the residuals is plotted here. You can check the residual as the case is laminar. So you can see UX, UI, UZ only. So now the residual is dropping well, and you can in these slices you can check the flow rate also, flow contour plot also. So these are things. Okay, So it's a simple case and stop. It converged in 49 iterations. Okay, fine. Okay. Now the next option is here we have post processing. So we can export the results to the format which we need for Fluent inside our VTK. We can export here, or directly we can load ParaView. So once we load the ParaView, it has taken the foam file which is created in the folder. You can see this one, and just apply. See the result here. Create a slice. Okay. Remove the pen. So click here and select velocity. And change the color of the contour. So here are 49 only, very simple case. So the main objective of this case is to check how to set up the case for OpenFoam. So I mean, with these results, creating animation is not good. So I'll go with only 3.5. Yeah. So this is how we can run the case using SimFlow. If you need, the other way is, like as I told you, a workaround. I'm not trying here, but I have tried for other cases. Once you create this folder, and as there is a limitation of number of nodes for this free version, what we can do is you create the case with less number of nodes and launch the case and see that it is running. And once it is done, you can take these case files to Windows subsystem where you have installed directly your OpenFoam software. So there you can launch the case in Windows subsystem terminal. So there you can you can change the number of cells in system folder. Like you open this block mesh. So here this is the number of cells in X, Y and Z direction. So you can increase the number of cells here as you require, and then directly launch the case using the OpenFoam software, which we can directly install from the OpenFoam website. The point to note here is, in this SimFlow free version, the OpenFoam installed OpenFoam is 2212. So if that same version is available, it works easily without any problem. But otherwise, you may have to play with the case to launch directly. Some parameters need to be changed, maybe some format settings. Okay, so this is it. So thank you.